Good morning, distinguished colleagues. I'm happy to welcome you at the first morning session. Considering that it is quite an early hour, I'm thankful for all of you for your participation. The topic of the session, geological exploration, resources for growth and efficiency. The topic is explained that the resources are unfortunately is a limited source, so efficient technologies and innovation in geology and exploration play a very important role. That is why the keynote speakers will share their experience and inform you on the technologies and innovative methodologies they use in their current activities. So I would like to introduce our first speaker, Pakhan Imazhanov, Director for Development, Director of Department of Digital Transformation of National Company Kazakhstan. Thank you, Paul. Good morning, colleagues. I would request to put my presentation on the screen. As Paul said, my name is Pakhan Imazhanov. I'm Director of the Department of Digital Transformation at Kazakhstan. Using the chance, I would like to share very good news with you. This year, the company is celebrating its 25th anniversary. Kazakhstan is a global leader in natural ural mining and one of the biggest companies in Kazakhstan. So, how we do digitalization in Kazakhstan, I will try to share in my 10 minutes. Just imagine a wave, you are at the shore of the ocean and you are covered with a big wave. Nowadays, the flow of data can be analogical to this wave. And some of us try to escape from this wave, but they fail. Other ones try to win this wave, conquer it, becoming a surfer. And those who manages it reach significant successful outcomes. In our company, we also would like to become the surfers. What we need for that? I'll share it. On the slide, you see the cycle of Technotype on Gartner version. When the new technology comes, always expectations are too high. And after the implementation, these expectations fail and hype goes down, and we understand that these technologies would not help us to increase, to double, to triple business, to increase it 4 times. And we start understand technology better and understand better in which area it is better applicable. Now we are somewhere between practical application and real vision of an outcome. The next step is the driving force of companies. You know, there are 3 types of driving force: people-driven companies, process-driven, and data-driven companies. These are human-centric organization where the human expertise is amazing. It is good and bad at the same time. It is bad when people are retired and experts are retired, the efficiency is lost. Process-driven companies is an opposition to people-driven companies. Here the main focus is on technologies and regulations, and any worker can be substituted. And data-driven companies, these are the companies where the focus is made on data, the analysis, and all the decisions made, whether operational or strategic, are based on the analysis of historic data. And in our company, we would like to find this code in the middle between people-driven and data-driven companies. All this you can find in our strategic document, Strategy of Digitalization. So by 2028, we want Kazakhstan to become an organization supplied with managerial and analysis instruments that use successfully historical data. And some words about our projects on data. The first project is corporate data storage. Data storage, in our understanding, is not data centers, but the system of analysis, collection, processing, and sharing analytical information for all the parties concerned. In this system, the data supplies are accounting systems, SAP, OneNest, industrial systems, including SCADA, all All structured and non-structured data are collected via the instrument and placed into the layer of corporate data storage. And then we have via-based instrument. All these data are interpreted and internal cases are shared. I can speak more details about this project in Q&As. And this next project is automation of pumping fleet. 89% of failures of equipment do not relate with the age of equipment. In this technology, we selected our centrifugal pumping station, which is in the heart of our geotechnical polygon, and we added sensors, and now we gain the outcomes that you may see on the slide. It is an increase of the resources of equipment operation, a reduction of cost for repairs, reduction of idle time, and improvement of quality of repairs. On the slide, you see real screenshots from the system. As you may see, we are measuring four indicators that include pressure, temperature, current, and vibration. We have a mathematical model that delivers us interesting cases and make prediction on probable failures of equipment. And the next case is the instrument allowing contouring the ore body based on the machine learning technologies. Geologists understand this topic of ore-body encountering. It is a big operation based on geological expertise, and in the company we have resolved this problem through automation of the process applying machine learning algorithms. So we have automated the contouring process and improve the analysis of geological data and improve the quality of collected data. On the slide you see that we were happy as our predecessors had the instrument Atom Geo, some database of geological data. We exported this data, processed them, and made geological modeling of ore body contouring and placed it on the map. I can share more details in Q&As. And the final case is a monitoring and control of the situation with COVID-19. We made in pandemic period. In March, we were remotely. It was a huge uncertainty period, and we are also operating in shifts, and all the decisions to increase the number of staff or change the shifts were shown on the slide. It is a real screenshot from our system BI. We collected data both from official sources and from questionnaires filled out by our employees every day. That's all I would like to deliver. These are the three cases I would like to present. Potentially we have much more cases, and I'm prepared to respond to your questions. Thank you. Thank you, Bahadjan. Colleagues, I propose if you have questions to the keynote speakers, please raise them at the end of the session. You'll have some time for that. And I would like to introduce our next keynote speaker, Alexander Frolov, Client Solution Specialist in Sequent Company.
Good morning, colleagues. I'm happy to welcome you all. My presentation is going to focus on how digital technologies can improve the efficiency of geo-exploration works, and we will look into a case with the junior companies. If we speak about efficiency of geological exploration works, usually it involves two options, two approaches: strategic, where we're dealing with development of junior companies development within a country, and the second approach includes technological approaches, meaning the use of various technologies. we will focus on the second one. This slide shows the historical data of innovations development in geo-exploration. Technologies that pop up within the last 70 years, which includes digital drilling, geological, geochemistry, and geophysics. The length of each interval is shown here. Time required to start exploration and remain in the markets, which is used by many companies. If you take the upper right side of this graph, you will see that these technologies are the latest ones, a couple decades ago, and which are being developed very actively at the moment. We They demonstrate great outcome in the form of production, greater production, and how the data analysis can be applied. I'm going to speak about Sequent Company and digital solutions that we offer. Our company is known through Leapfrog, but our portfolio includes many other programs which are combined into a single ecosystem and aim to address a number of complex problems in geo-exploration. We know that geochemists, geologists work in different soft, and it's a rare case to satisfy the needs of everyone. Therefore, in sequence, we focus on the development of ecosystems, allowing all kind of disciplines to be combined and to exchange data without importing or exporting and losing information as a result. Here are some examples how this software can be combined. Hopefully you can read it. So on the basis, uh, our product became popular among many companies, uh, junior companies in Canada and the United States, and this allows us in our solutions and the functional intended by designers helped us to create a quintessence or a combination of simple recommendations intended to improve efficiency of your operation. So we splitted them. This is the leaflet, the reference book, which is available in our booth. We split this into a number of steps on how our customers work with data and how we put this workflow into the software. And I'm going to move through all of them and take you on focusing on each. The first one is a collection of geological samples. We are limited by a field season period, and when we go there, we need to know what kind of data we are going to take, which kind of imageries we are going to process, and so on. For that, we created MX deposit, which allows us to have a database ahead of time of the format that we desired and use it through mobile app. You don't have to take any extra devices for that. And the work is very simple. You put your app on a on a tablet or mobile and work with current or other formats. It's a cloud-based solution. You don't have to run any extra costs to maintain your server or any other extra costs. The technology can be deployed within a couple of days, and the training is very fast, and it proves to be effective, mostly outside Russia, outside CIS. It's not very well used here in this region, although, but it's a matter of time. But we know that the next one is the drilling work and geophysical methods. They help us to reduce the volumes of drilling and to be more precise in terms of exploration effectiveness. Geophysics is also very important, and we have Oasis montage solution, which is quite standard and well known to many of you. It allows you to process all types of geophysical data apart from seismic. I also wanted to speak about OXY module, which allows you from your field images to transform it into OXY models to computate the data for 3D processing, and our ecosystem allows to transfer data to enable data flow from Leapfrog to Oasis to other programs, to other software. The next step is the drilling plan. And here, based on our interaction with Canadian juniors, our products have been used for decade more over the decade in Canada and many other countries, and we understand that rock and the companies usually have limited budget. So we developed Target, which allows to combine geophysics, geochemistry, and geological data, and to have a kind of a framework solution to compile all kind of data for the planning of the drilling. It can be used in Leapfrog, but Target is characterized by its better functionality and its universal nature, and the cost is lower, therefore it looks much more attractive for juniors. The next step is development of geological models. I want to comment here that quite often we believe that geological model is something which has to be done once you finish the drilling phase. But from international practice, we know that it's an old idea. Many advanced companies, before going to the fields, tend to create geological models when on the basis of geological map you can design this model, add up geophysics and other data available at the moment, and develop some kind of a well-designed geological model, allowing you to plan your further geological exploration work on the next stage. It gives you a better and more precise understanding of where to drill and what would be the best way to drill. Leapfrog use a conditional implicit modeling, allowing you to upgrade a model automatically once you have new pieces of data. So on each drill, you can update your model, and you always have the most relevant and reliable data for your further steps. The fifth step is assessment of resources. Many companies tend to outsource this service from consultancy companies. However, the Module H in Leapfrog allows you to do it independently and not to outsource this service. There are two ways how a company can do that. And every time, once they get results from the lab, they do this work by themselves. After that, they come to consulting company, and consulting company will finalize their steps for LSE, for exchange, uh, commodity exchange, and so on. But many of them can do it independently with the Leapfrog. Leapfrog is a great tool to create it and also to review. And also, data management is one of the priorities. We know that in junior companies, geologists, geophysics, drilling specialists quite often have to exchange big amounts of data, and exchange is a very important process. This takes quite a long time. It's lengthy, and the product central allows you to store all geological models that you developed and exchange through cloud-based solution, cloud-based process with your colleagues. with your colleagues or with the other software products, such as Vice Montage and Mix Deposits. They communicate through the central, and you can obtain data from your colleague at any time via the clouds. And the most important thing here, you will use the latest version, the latest updated and most relevant version, instead of having something from your server storage place. And this can be applied in all stages. You can use it at the very beginning, and you can come you can use your digital model. You can verify at any time who developed it, it was added, how it was changed, and you can compare your historical model at the beginning with the up-to-date version. If you take your mobile phone, if you open QR code, you will be able to see how this new technology works. So this is the way how you can develop data, how you can share data, share with your colleagues, investors, and so on. Again, our clients' feedback told us that quite often they fail to properly demonstrate their data. So this cloud-based solution enables them with this function, enables to provide access to this data, and actually you can do it for any purpose. You can be more precise. You can sound clearer in front of investors and so on. Thank you. With that, I conclude my presentation. Thank you, Alexander. Once again, let me remind you that all presentations of the speakers who present today will be available on the MINEX website. Our next speaker is Tim Archer, Managing Director of RIT Geophysics.
Could I have the slides, please? Thank you. Good morning, ladies and gentlemen. Thank you for the opportunity to present today, and to MINEX and to the UK Department of International Trade for making that possible. It's an exciting time to be in mineral exploration, both for conventional resources and also, of course, for the transitional resources that are so important as we aim to decarbonize our global economy and also to secure sustainable supplies of critical minerals needed to sustain our 21st century lifestyle. Because of the excitement, because of the market increase in demand for both traditional and transitional minerals, there's a huge amount of geophysical technology available. And sometimes the difficulty is that mineral explorers who need that technology are somewhat overwhelmed, as we saw in the previous slide, with the wave of data, the wave of technology. And how do we steer our way through that? How do we know what technology is going to be appropriate for individual exploration problems? Where we as a company, RIT Geophysics, is a geophysical consultancy, and we sit in that space between the providers of the technology and yourselves as consumers, and do our very best to advise on what's going to be most appropriate for your particular project and applications. In particular, we're able to assist with survey design, with contractor selection, with the quality control. We've got a bunch of data. Does it look like what you've paid for? Processing and interpretation of those, often working with your local team here in Kazakhstan, and also modeling and integration. That's really important. Geophysics serves the geological model that we've seen in previous presentations. If we don't know what's in the ground, we're not going to be able to extract it and mine it. Geophysics is helpful in that regard, but it's not the end product. We need to be working with our geological colleagues and colleagues across the broader disciplines to make that work. And then, of course, we provide technical training. You know, we're headquartered in the UK. If you're doing work in Kazakhstan, you've got a local team. We're in a position to upskill your local team to make use of these data. Importantly, though, we don't, as a company, collect data. We are independent. And for that reason, we're able to advise you on best technology worldwide that is specifically applicable to your exploration problem, rather than just what we have to have sitting on the shelf. So we feel that's an advantage. My talk today is going to cover four main aspects: reducing risk, the geophysical methods available for that, recent developments, of which there are many, and then a few case studies. Finding mineral deposits is difficult. There's a range of challenges. These can be political, logistical, and technical, and I've listed some of these here. In general, what geophysics aims to do is reduce risk on a project. You've got a huge piece of Kazakhstan, you have no idea what's under the ground, perhaps you've got some Soviet era mapping, but not as much as you need. Our recommendation, not always, but often, is to fly an airborne survey using a fixed wing or helicopter system, or possibly increasingly drone surveys are becoming popular. And in that way we reduce the risk. We know where to put in the heavy expenditure, where to put in the field teams to do the sampling and ultimately the drilling. This is just an illustrative graphic. On the left side of the slide there is a single, perhaps 200-meter exploration borehole. And for that same amount of money you can shoot as much as 160 square kilometers of airborne survey. Some of the numbers smaller as the technology gets more intense and more costly. Even for ground surveys you can rapidly characterize and de-risk a large volume of ground. And of course geophysics is non-intrusive. So from an environmental and safety point of view, it ticks a lot of boxes. This is a busy slide which I'm not going to go through in detail, but I encourage you to study it in the recorded presentation in due course. It's just a really useful graphic indicating what kind of geophysical techniques are available at the early stage: mapping in green, detection of individual deposits in red, and downhole logging in blue. And acknowledged Dentith and Mudge for much of this work. So do take a chance to look at this. It's not definitive, every project is different, but this is a useful starter. Geophysics works at different scales. Many of us know that from the regional, indeed the national scale. We recently had the privilege of being the technical support and quality control on a nationwide survey of Sierra Leone in West Africa. That was a World Bank funded project, possibly a useful model here in Kazakhstan. So countrywide, through to license scale, prospect scale, and even downhole in a mine environment. So it's a scalable technique, scalable methodology. Just some recent developments, and I could talk about this all day, and you'll be happy to know that I'm not going to. But there are a large number of recent developments, both in the airborne space. These are three technologies. Geophysical equipment always looks odd. Mostly that's because it's trying to do a very difficult job in challenging circumstances. We're taking, with the instrument on the left, or the contractors are, measurements to within 1 in 1,000 million. Roughly amplitude with gravity gradiometry. It's a very precise measurement. You put it in an aeroplane, you throw it around the sky. This is difficult to do. Full tensor mag gradiometry. We've had mag technology available for the best part of 100 years, but the people are pushing the envelope, getting better information, more detail, and getting toward a stage where we can characterize a deposit almost remotely. I'm old-fashioned, I still think you need to drill a hole, but it's where you put the hole that's important. And then AFMAG, essentially a flying variant of magnetotellurics. Very happy to chat about all of these in more detail for those of you who are interested after this. Ground geophysics is no less active. The image on the left is from a contractor website. They're able to run a combined resistivity-induced polarization magnetotellurics survey, 4 square kilometers in 3 weeks. So you get a data cube, 2 by 2 by 2 kilometers, give or take, within 3 weeks of acquisition. It's very rapid, highly diagnostic. This technique looking at electrical properties of the subsurface. All of the geophysical methods rely on variations in the physical properties of the ground. If there's no physical property, you can't use that type of geophysics. But it's often the case that even if one technique is not appropriate, another will be, and there's a skill to designing those. We're seeing a lot of integration now, and we're talking about this in a couple of slides, between downhole geology, geochemistry, and geophysics. The disciplines need to talk to each other. There's no point doing geophysics in isolation. It has to be informed by our friends in geochemistry, in geology, and actually broader, even to the extraction stage. My previous slide, you can have a wonderful deposit. If it's refractory or not mineable, you don't have a mine. So we all need to be talking to each other. Subordio magnetic's fascinating. You run an EM survey and you measure it with a magnetometer broadly. Again, more details, but that's very useful in areas of conductive cover. Drone surveys. Drones are cool. We all need to know about drones, but they are genuinely becoming mainstream. So we're seeing them fill a useful space now between ground surveys, particularly in areas where security is a problem, where access is a problem, perhaps boggy ground, arid terrains. and between that and the airborne systems that are still running the multi-thousand square kilometres. Drone technology is coming up fast. And I'm actually on an international committee at the moment drawing up guidelines for best practice in drone geophysical survey. Some of the images here from the contractor websites. Just briefly, some case studies, and I have an apology first. I was hoping, we've done several projects here in Kazakhstan in recent years. Unfortunately, none of the clients were willing to allow me to share these data. They're all private clients, and obviously we respect that confidentiality. Just in general terms, though, we've been helping clients look for gold in Aktobe, polymetallic, a broad range of commodities actually in North Kazakhstan, and copper in Don and Jambul. Interesting work, a combination really of ground and airborne, and typically advising clients, pulling the data together, beg your pardon, both historically and modern data sets, training up field teams on how to collect good quality data, and then making sense of it all, again, with our geological, geochemical colleagues. So we've had a lot of fun in Kazakhstan. We believe we've done some good work. Very much looking forward to working with some of you in future. I will show you a case study. I'm afraid this one's from West Africa, but it's a lovely example of how integrated geophysics can work well. The end result, this will be a mine. It's a 1.2 million ounce gold at reasonable grade, and I'm grateful to Perseus Mining for permission to publish this case study with you. A lot of words on this slide. Roughly, we've got structural hosted gold. It's pyrrhotite hosted, so of course with that you get a conductivity and a magnetic signature associated with banded iron formation, so lots of magnetic content, and preferentially concentrated in steeply plunging fold hinges, so there's a structural control. From a geophysical point of view, it's a dream project, and obviously that's why I'm showing it to you today. The terrain is horrid. This is what we've got. That's about 600 meters amplitude across not a very large area, so it was always going to be a helicopter job. And two techniques were flown. One Midas, flown by Excalibur here in the audience, magnetic and radiometric, so measuring variations in magnetic content, and radiometrics, as some of you know, flying geochemistry. We're getting potassium, thorium, uranium, that tells us about alterations, granites, that kind of thing. And then a VTEM survey specifically to look at conductivity, electrical signatures, often of that pyrrhotite and mag again. Survey parameters here, but I won't go into those. Here's the ternary image. These are pretty pictures really, but a lot of detailed work was done on these. What we do here, we combine the thorium, potassium and uranium as a multicolour plot, and this is, as you can see, that's pretty much a mappable image right there. So with geological control you can really do a good job. Here's the magnetic image, lots of signal coming from the banded iron formation, and banded iron formation particularly tricky because it doesn't magnetize in the same direction as the Earth's magnetic field, but we've got techniques to help with that. Electromagnetic, so you can see where the pyrrhotite's sitting, the warm colours here, and we tie it all together using the high mag to magnetic susceptibility to find the banded ions, the electrical conductivity to find the massive pyrrhotite, and bringing in some soil chemistry and of course some artisanal mining. Historical working has been done here, very important layer in your exploration data set. Don't miss out on what the old timers have done, they knew their stuff. Target generation, as you'd expect, and fine, we've got these 10 or so prospects, but this is geophysics. Did it work? Well, the answer is yes, it did. In their first intersection hole, they got the grades that might be a bit difficult to read here, but a large number of meters grading up to 11 grams per ton. So yes, it's working. And again, geophysics was not the end result, but what it did, it generated the targets that enabled the clients to site the drill holes in the right place. Yeah. Just going to talk briefly about machine learning. We're pretty excited about this. Artem Gorbanov is our specialist. He's in the audience here today, so ask him the difficult questions, please, not me. Thank you. This, again, fairly busy slide, just really indicates a useful paper here, which you can look up, the huge volume of techniques available bottom right in the machine learning space, and the number of papers that have been published. That dip there in 2019, possibly partly due to pre-COVID, but also to the fact that that was just the first 8 months of that year. We're seeing a real surge in this, and again, we need a roadmap to navigate through this forest. Some techniques are very much more useful than others, and we're at pains to determine in the mineral space which of those are going to be most helpful. Just going to show you briefly, this is a test area. Again, we're not in a position to show client confidential data sets, unfortunately. This is a well-explored area in Quebec, Canada. You can see the location bottom left on the map there. General geology, a lot of mafic, ultramafic units here, some felsics in bright yellow bottom right, and sedimentary cover coming in over the top. We're just looking at the green rectangle in the middle. We dialed in the Bouguer gravity, the magnetic intensity, and the apparent conductivity, so 3 different product streams, and we tied those all together. And this is fairly preliminary work, but we did a clay-means cluster here and self-organizing map on the right. These are the first stage in our interpretation. What we then do is we tie it back to the existing geology, and importantly, for me the most important application of machine learning is to challenge our subjective interpretation. As humans, we develop a way of interpreting data, and that way is not always complete, not always accurate. So we use the machine not to do the work, but to challenge our presuppositions. So it's a very useful tool in that regard. Slightly more advanced technique here, convolutional neural network, where we literally took the magnetic image and said, where are the lineaments and how deep are they? And that's an awful lot of work that can be done. You can see some noise in these data. This is preliminary work. We can clean this up. We're grateful to Napstek and Smith for the source algorithm for this. There's a huge amount of work in this space. It's all about navigating to what's going to be most useful for your project. So in conclusion, the demand for conventional and transitional resources is, and we believe will remain high. Finding new mineral deposits is not easy, particularly as they get deeper, particularly as they get undercover, particularly as the global economy becomes more competitive. Geophysics can de-risk projects at a range of scales. Regional, license, prospect and mine scale, we use slightly different techniques to zero in on the mineralization. You're still going to need to drill the hole. We can tell you where to put it. A range of methods is available, as you'd expect, and there's a real skill to designing. It's not a one-size-fits-all. Different techniques will work on different occasions, different projects. And hardware, software, and the associated expertise is improving all the time. Please do contact us. We're both here for the rest of the day and obviously online. We'd love to talk to you, and thanks very much for your attention.
Thank you for your presentation, Tim. It's very useful for understanding your achievements in the area of modern geophysics. Уважаемые господа,
Distinguished ladies and gentlemen, I would like to invite the next speaker, Vera Belausova, geophysicist engineer from exploration company. Good morning, colleagues. I have been already introduced. The topic of my report is a search for solid minerals on the basis of innovative adaptive standards of geophysics on Earth, in air, and in underground. It is known that geophysical methods is a reliable tool for prospecting searches. It is a difficult work and financial process without guarantee of success, but we can minimize the problems through so-called correct geophysics, which success is based in the application of innovative technologies and identification of useful signal from prospecting objects on the background of noise and with a focus on geophysical geological models of deposits. We have 2 stages of geophysics surveys: large-scale aerial geophysics and on-the-ground geophysics. In total, we can identify 3 subtypes of aerial geophysical surveys based on the carrier: plane, helicopter, and drone. One of the efficient methods of large-scale air geophysical surveys is a set of searches based on super-light piloted aviation. On the slide, you see the location of magnetic survey sensors on the plane. They can be stitched to the tail or to the wings on special platforms. On the slide, you see also the location of air gamma spectrometer on the basis of a SP-38 superlight plane. In the lower part, it is placed in the plastic container, so the fuselage or the body of the plane does not prevent the flow of gamma quants to the Earth's surface. That improves the quality of the surface. It can be, any plane can be used with a shortened runway.
Joint stock company Georazvedka has its own design of helicopter Impulse A. This platform is intended for comprehensive airborne exploration works. So and surveys up to 600 meters depth. This platform is attached to Eurocopter or Mi-8, and in the height of in the height of 150 to 100 meters over the surface of land. The speed is 120 kilometers per hour. The transition method is based on the two-loop principle, where we can split between the induction and polarization modes of the signal that we measure into vertical areas of the sensors. Here is an example of gold mine deposit in Mountain Shoria, and in accordance with the geomagnetic survey, we made a precise images of the borders of this deposit. Mass spectrometry allows to detect anomaly fields and to define one of the indicators proving the reserves in this particular spot. And also we clarify the morphology of walls. As a result, we made an analysis with the classical survey triage. We identified the trajectory of geothermal water flows, and as a result of drilling, we confirmed the high probability of the survey results, not only the depth, but also the industrial forecasts of further development of these gold deposits. The company EM Razvedka developed the system for measuring of the loop, and this loop has a diameter of 80 centimeters. The size the size of this loop in the field it covers is 250 by 250 meters on the surface of the land. It follows two parallel routes. The height can be preset, and so this slide shows the picture how it looks. So here is a set for the ground geophysics with technology impulse descent, which is intended for electricity commutator and measurements. KT200 is intended for the survey up to 3.5 to 6 kilometers, and KT50 for in-depth surveys, and also for electronic magnetic tomography and many other things, many other areas. And also they are applied the Impulse D21, which you see here in the image. It's a multi-channel diametric system with the high frequency of discreditation of the final results of the process allowed to have high frequency service intended for engineering small depths and deep depths data. On the ground survey, which are intended for detection and for the survey of the ore bodies, and also for the survey within the parameters of geological layers. The system is designed by AM Разведка, by the company. Its geometry may vary depending on the tasks that you want to perform, and also taking into account the conditions of the terrain, water or snow, and the system is pretty resilient. It can be assembled and deassembled. This construction consists of the framework and cylinders, and it allows to detect between radioactive and inductive types of signals, which improve the quality of data that we collect. So the depth of survey is 10 to 2 to 300 meters, and the system can be used for the mapping of tectonic layers, and also for dissection of precipitation layers, and for polarized objects detection, such as solid minerals, technogenic objects, and underwater, underground communication.
On the slide, you can see the outcomes of the works carried out in Quebec using electromagnetic tomography. Actually, electromagnetic tomographer was adopted to operate in narrow forest roads, and actually this data allows you to see the zones of increased conductivity, which is associated with gold ore objects. And also on this slide you may see the comparison of cross-section based on electromagnetic tomography and electric tomography. Based on the data of electromagnetic tomography, first of all, the information is more detailed and it removes some technological noises. We have to say a couple words about the software for processing, assessment of the data that we are using in the company. They are in-house software complex UNDP. The key capacity is qualitative assessment of information and qualitative assessment of single and special pickets, and also dot-based inversion of pickets, 3D inversion, and automated division of inductive and polarization signals. And also imagery in 2D and 3D, as well as import and export to various formats of data. Elvira, sorry, but the time is pressing. We we have to listen to other presenters' colleagues. Let us thank Elvira. If you have any additional questions, you are welcome to ask them. With regard to the presentation, please address Elvira both within this session and after it. And now I would like to provide the floor to our next speaker, Sergei Petrov, Executive Director of LIMS. First of all, thank you very much. I'm thankful to the organizers of this big conference for the opportunity to present the outcomes of our surveys. Couple words about what is LIMS. LIMS is a laboratory for mineral study, being a professor of geology department of St. Petersburg University. 20 years ago we started providing geological services, and all this resulted into the laboratory for studying the minerals. Now it is a group of companies that where we have more than 100 employees. This group of companies based at St. Petersburg at Ural region. Now we are covering the entire range of operations. We can do any works in terms of the study of the substance and the age of geology. And it is continuing to be a professor at the university because I'm working with my students who are dealing with geophysics and geochemistry, with geological prospecting and with some geological and structural surveying. We actually can do any types of operations. And the second aspect is related to the works that we are going to present. Here we are going to present three aspects related to the methodology of territorial study for potential porphyry systems. As you know, there are a lot of moments like that, and I actually love geologists and geophysicists, but now I'm going to talk about geochemistry and mineralogy. This is a methodology cannot be completely applied anywhere. We apply it only partially because it is very difficult to convince a subsoil user that the whole cycle of this work is needed. Actually, we're in the situation of a patient and a doctor. When a patient knows the disease much better than the doctor. So, the first stage is geological and genetic modeling of our systems. I would provide you an example. It is a huge territory of northern Timor, which is operations have been carried out after the order from one of the biggest oil mining companies in Kazakhstan. The territory is poorly studied, as you may understand. We have only episodical physical and geological observations done by high-level class geologists, but the territory is 14,000 square kilometers, equal to the territory of Montenegro. You see everything is red. There are huge amounts of granites, and we have to understand what actually they are. What do we propose? We propose to use the dimorphism of minerals, which is accessory intrusions in these granite masses. We use it for a long time when we are studying, we're doing isotopic chronology. And these aspects do not raise issues that for isotopic dating and for identifying absolute age of giant massive at huge territories that we are used nanograms amounts of rock. This is chemism of zirconium, apatites, badellite, magnetite, and calcites, and a lot of minerals. Actually, it is a fingerprints of magmatic sources from which deposits of minerals were formed or could be formed. And in the most recent 4 years, those who are following the literature, you may have observed a lot of literature on this topic, and we have connected to this topic, and about 2 years and a about 2 years, we were convincing the company to perform this work, and during a half year we have carried out this survey where we identified a lot of absolutely interesting indicators of granite magmatism in huge territories of northern Timor. We identified geological petrogenetics of granitoids, the source of magma, and evolution of magmatic source. So we have identified about 30 various characteristics, and based on these characteristics, we made the conclusion that these objects are poorly prospect because they are significantly eroded, and for the companies they are not interested. And this massive of lead and wolfram are also out of purpose, and also we have all three massives, and this group of massives are little promising. It is a second type for geological operations. But these couple massives which are interesting that deserves focus of attention for at prospect stage. And the price of an issue is 50 meters of drilling in our equivalent. Actually it is timer price, but still I turn them to meters. The next stage, we have identified the method and the target where we have to place geological prospects. And to do little geochemistry, we can apply different methodologies, and they are numerous. We propose our own patented methodology, which is patented at Europe and Russia. This methodology allows very precise analysis of required elements for geological and genetic modeling, and we can directly identify the grades of noble metals and several type and morphic impurities, which are very important for this geological geophysics survey. It is a cheap and simple method which is environmentally friendly. We do not use reagents, and it is based on polyelemental analysis, LACPMS, with laser ablation. Based on these outcomes, now you can see the example of a section of an area in central Kazakhstan. The work also has been fulfilled on the order of one of the biggest gold mining companies in Kazakhstan. We have carried out a geochemical survey, and we carried out analytical studies based on our methodology, and I provide only certain examples of maps, and I would like to show that the anomaly of thallium and other elements help us to move the focus of prospect and more difficult geological works in the territory. And in the southern part of the area you can see the zone not for copper porphyrite mineralization, but for geothermal mineralization. It could be also a latent mineralization. You see, a huge massives of geochemical data requires processing. We can use any methods which include statistics, neural networks, machine learning, whatever. It is important to understand what you include into your processing algorithm. What are you actually processing? If you do not consider geomorphological factors, if you do not consider characteristics of aquifers, if you do not calculate the grade, you'll get just artifacts. In our operations, we applied factor analysis for modification of main components. It was quite sufficient. Considering geomorphological factors, one can identify homogeneous geochemical domains that can be later used for geological and genetic modeling of ore and magmatic system or metasomatic system, but still it is huge based on the result of first process in the area for exploration reached 16 square kilometers, and the application of our methodology says that it is actually bigger because the center of ore bearing system is moved towards north of this territory, and it does not cover initial prospects. What we have to do with that? I'll respond this question later with the application of high accuracy methodologies and identification of several type and morphological elements in samples of soil allow us to get necessary information. First of all, we move the center of ore bearing system from which is very straightforward, but actually it's occurs a little bit to the north. And also I would like to mention that we have gold content. Actually it is sulfidization type, and these objects can be quite volumetric as outcropping is not significant, but the zone of closed mineralization is quite significant. On this picture you can see the anomalies of thallium gained on the level of ppb concentrations, and what we can do with it, and what is the price of our methodology is also different from other types. This methodology is comparable to the most advanced methods like MMI and other methods of identification of flexible forms. The methodology appeared to be productive and quite non-expensive. That allowed us to dense the networks if it is required within exploration issues. And what is the next stage? What we can do with these huge anomalies? I'll give you an example from other area. It is southwest reach of Okhotsk terrain. It is a huge complex anomaly for copper, molybdenum, gold. Everything is surrounded with industrial gold. And what can be done with that? We will do mineralogy survey. We study mineral composition of metasomatic formations and construct maps of mesosomatic rock distribution within the anomaly. As a result, we get the trend of changes of metasomatic associations, and we get mesosomatic zonality that allow us to design drilling profiles not using square and cell methods, but we have a model for that, and drill holes. Actually we have 3 holes of 300 meters depth allow us to construct a geological model. Whether our model will be confirmed or not, it's a question, but the price of this issue is 200-meter drilling. But if we are dealing with the study of metasomatic association with infrared spectrometers, in this sense, it was me. I get it for free. It is a work of a student of the third-year study. Actually, it is his third course work. So we propose sequential operations. These are the operations that can be done within the same season and quite cheaply get geological and genetic models that will be the basis for appraisal works and for exploration activities. And I also would like to advertise myself as we are able to do that. Please approach us. Our booth is in the second room, close to British Embassy.
Спасибо большое.
Thank you, Sergey. Our next speaker is Madim Ahmuduli, a leading geophysic from Aurora Minerals Group company.
My presentation will be in English. My name is Madim Ahmuduli. I'm a senior geophysicist in Aurora, and I'm here today to talk to you about capabilities of high-resolution magnetics in iron ore exploration. So briefly, it is a combination of geological routes with sampling and ground magnetics to cost-effectively assess targets' prospectivity at the early stages. So first, briefly, our test range is located in central Kazakhstan region in the most well-endowed mineral terrain. Our target, the daily surface, is rugged terrain. In the geology is uneven, and the river basins are mostly covered by alluvium, almost half the territory. So the regional geology is represented by massive granitoid intrusive body surrounded by calciferous sediments, and we surveyed most of our geological routes and collected our graph samples along the edge of this intrusive body. So this contact is quite visible from the surface, where we can see massive magnetite outcrops there, and we collected most of our graph samples there, so we literally walked over the magnetites. So our object is typical calcic skarn mineralization, calcic skarn magnetite body, located along the edge of the intrusive, and skarn mineralization formed 3 kilometers long contact zone where numerous commodities like tin, iron, and lead and zinc have been reported earlier. After geological routes, we did ground geophysics, particular ground magnetics with 37 meters line spacing, and you can see this skarn mineralization forming massive magnetic anomaly. Here. So that contact zone with magnetized skarns is clearly visible, and our magnetic field has magnetic anomalies of more than 90,000 nanoteslas, where IGR values averaged has 56 nanoteslas. So look at the positive values there. It reports us more than 90,000 nanoteslas, and you can see that magnetic field along this skarn has a complex character. It has both positive and negative values of residual magnetic response, and its amplitude sometimes exceeds 30,000 nanoteslas. So we counted the zone. Where amplitude exceeds of 30,000 nanoteslas, and samples collected from there report 40, 50, and up to 60% of iron grade according to different analysis. So as a result, we did the correlation between 30,000 nanoteslas and averaged it to 45% iron grade. So this is the demonstration of such correlations. So we literally walked over this magnetite body, so we have a right to say it's like 30,000 nanoteslas corresponds to 45% iron grades. And these are the samples showing it's high magnetite contained minerals there. So the main idea of this project is to build a geophysical model of the depth using innovative approach, 3D, three-dimensional vector magnetization inversion. It's a Voxy cloud-powered inversion supplied by Sequence Oasis montage software. So the principle of this inversion simply is that it takes into account inclined magnetization of iron content minerals. From the previous slide, you could see it has a complex field with both negative and positive values. So if it would be a traditional approach, the magnetic susceptibility would divide our magnetic dipole into two different bodies, where in fact it's one body just with a complex magnetic field. So this approach works better on our side, and rather than the traditional approach, the magnetic susceptibility. So to generate this model, we need to clip our MVI value, which would correspond to our 30,000 nanoteslas area, and in turn a 45% iron grade. So in this regard, we iterated multiple models. We simplified this current contact zone into a dike form with a known formula of induced magnetization. So based on this formula and taking into account the wavelength, the character of the anomaly over the magnetite body, we clipped the MVI value into 0.05 SI as a conventional boundary between rock and ore with cutoff grade of 45% iron. So, and we tried to estimate the resources based on that. We created isosurface of 0.05 SI value, and Geosoft as montage advises the dimensioning of this isosurface equal to 40 million cubic meters, and we took this 40 million cubic meters multiplied to our density 4.5 grams of the skarn body, and as a result we get around 63 million tons of iron grade 45%. So to confirm this method, we need to just one or two diamond drilling, so we can after that analyze the core samples. We can move our MVI value and play with their parameters and recalculate, remodel our model and making it closer to a true picture. So to sum up, the framework done is that we do geological roots with samples. We got averaged 45% iron grade. We do ground magnetics and see highly magnetic anomalies corresponding with 45% iron grade. And with this, we calculate, we build the MVI inversion, which works better on our side. We clip our value to 0.05 SI value and use this as a conventional boundary between rock and ore. We can dimension these bodies and more or less estimate our resources. Finally, we check it with a selective diamond drilling, and instead of entire area drilling out, to understand the real boundary, and then we remodel MVI value and can recalculate the resources. So as a conclusion, I would say that MVI value is a cost-effective method to assess the project at an early stages of exploration, and this method can be applied not only for iron ore objects but other minerals, other targets associated with magnetic minerals like iron, titanium, nickel, cobalt and other commodities. So, and as a continuation, I would like to present that Aurora AG is a part of Aurora Minerals Group, which provides the full chain of exploration. We do starting from licenses, geological supports, full range of geophysics, ground and magnetics, diamond drillings, and JORC report. And recently, we'd like to announce that we did the exclusive partnership with the world's leading airborne solution company, Excalibur Multiphysics. And I would like to give a word to our operational manager of Excalibur Multiphysics, who would better present their capabilities. Bart Anderson, please.
Thank you, colleagues. And thank you for all the presenters that have come before. Excalibur, working collaboratively with Aurora, is pleased to be bringing its broad range of technologies to Kazakhstan. We're going to be bringing the complete range of our technologies: magnetic, radiometrics, electromagnetics, gravity, graviometry, both on fixed wing and helicopter platforms. So we'll be bringing in a number of aircraft into the country. This will allow Aurora and Excalibur to offer the most appropriate solutions for most exploration challenges. We're a global company, and we're very pleased that we're partnering with Aurora in Kazakhstan, and we'll be offering these services from the operational base here in Kazakhstan to not only Kazakhstan but the immediate region around it. We have a number of operational centres around the world, but what we do believe in is developing locally. You can see the amount of officers, the amount of aircraft, the amount of people in the slides there, but we also plan on developing people and working collaboratively with the industry here to expand the offerings in Kazakhstan. Lastly, for those who don't know, this is what we do. These are some of our more popular offerings. The first is Falcon and HeliFalcon, which is a leading airborne gravity gradiometry technique. We're one of the only companies that can fly airborne gravity gradiometry on a helicopter, and we're the only ones who have done it commercially for the last 10 years. Tempest and HeliTem are our EM offerings. Tempest is a great mapping tool for minerals, for water, for countrywide mapping. We're currently flying another phase of Australia where the plan is to complete full coverage of the country with Tempest EM. Our HeliTem offering offers the lowest base frequency worldwide. What that really means is you can see the deepest under any cover. It really specialises for discrete targets under very conductive cover. And lastly but not least, our magnetics and radiometrics offerings. For the most part, we fly all our mag-rad in fixed wing in an air tractor. That allows you to always have gradient mag and also to be very, very low. So we typically fly these air tractors at 35 metres. In heavy terrain or where you need to be lower or have a closer spatial resolution, we offer the same on a helicopter. If anybody has any questions about what we're offering, please pop by the Aurora Excalibur booth. And thank you all for listening.
Спасибо большое, уважаемые коллеги. Завершающий доклад.
Thank you, colleagues. And the final presentation will be made by Yuri Devetenko, executive. By Yuri Devetenko. Good morning, distinguished colleagues. I'm happy to welcome you. So we represent Siberian School of Geoscience. It's a separate institution at Irkutsk Technical University. I have to mention that we have combined in the university several companies, several research teams. One of them is my company, Gelios, the outcomes of which works will, in the territory of Kazakhstan will be presented today. We will discuss what is porphyroid system as an object of prospecting. We'll talk about electromagnetic sounding and visualization, and we'll discuss Kansha key area. The operations were carried out in 2018-2020 in the territory of eastern and northern Kazakhstan. On the slide is a typical picture of porphyroid system. If you look to the right, you see a porphyroid system which actually is the most possible in several regions. In the center of the system, you see the mineralization, which is much lower than in the perimeter. Actually, the fluid takes sulfides outside of porphyroid systems, and later you will see how it is reflected in geophysical fields. We made direct modeling before the surveying. The object contains a lot of contrasts, and this appendix is very well identified on the background on significant deep occurring object, both in magnetic field, and at the right you can see the schedule of transition process from initial line. These measurement systems have been successfully applied both in Kazakhstan and in Russian Federation. We register transitional processes from a long line using receiver line of multi-channel measurement system. It seems quite ordinary and very straightforward. It is an ordinary method of medium gradient, but actually it is not so. We register the oblast of impact of electric magnetic induction when the field is distributed in magnetic environment. It is similar which we have from this loop source, but we simultaneously get the response from polarization as the current runs through the environment. So we get three sources of information: is conductive field, electromagnetic induction, and polarization. We have developed and we apply equipment in Kazakhstan. We apply strong powerful generator for 30 kilowatts and commutate and Soviet design commutator provides up to 20 to 30 amperes. So power is a source of success. Software is also developed by us or by our partners. In this case, it's Mars 1Z software that allows to make modeling within horizontal LED environment for various installations. After we have analyzed the outcomes of the survey and changing the parameters of electric resistivity caused by polarization, we came to the conclusion that we will not mix these parameters because the curves are significantly changing and significantly different, and this is a serious advantage. Significant anomalies caused by polarization do not cover the change of electric resistivity, so we can distribute the object with high polarization and high ohmage objects. If we look, so actually we can definitely see the model. Software for three D inversion is developed by Marina Pirsova, is a Department of Applied Geophysics of Novosibirsk University. Our specialists are using the same software product, and we have to say that in our team we have all modern technologies. The first of all, technology of loop line when we move from long cable, and also we use spectrometry, magnetometry, and LiDAR scanning. We are prepared to provide this service as territory of Kazakhstan, and our client for Kanshaki preferred to use the technology of geoscan. The height of survey is 40 meters and speed is about 20 kilometers per hour. But to process this data for 3D inversion, we do our in-house software product allowing the recovery of magnetic susceptibility, magnetic inductive magnetization and residual magnetization, and we will be happy if the survey is high quality and the object have different residual magnetization that would allow us to identify various phases of organization. In this case, you see the outcomes of 3D modeling of the object at Kanshaki. The polarization is shown in red colors and resistivity is shown in blue colors, and round structure is very well seen, and also you see some number of wells drilled based on our forecasts, and the table that shows the outcomes of the area of mineralization. And I have to mention that actually only one hole that was recommended for drilling did not provide positive outcome, and I'll explain why. Because we are dealing sometimes with very contrast objects, and if you are making a survey at the edge of your prospect area, there is a chance that the object which is behind your border can have significant impact on the things we registered within the survey. The first processing of data of magnetic survey shows that this object is located to the south. This is the outcome and verification of 3 model. In red you see anomaly caused by polarization, and these local objects have been identified thanks to 3D inversion of the magnetic field. We are talking about those red bodies. I have to mention that the object with maximum concentration of iron especially complies with identified objects based on anomaly magnetic susceptibility. In arrow you see the magnetization vectors. In arrows, I have to say that in this object we identified sulfides. First of all, pyrites. We identified copper, but it was not in significant amounts. But actually, the client did not have enough budget. It is a story of a junior company, and we are sure that at this prospect area, one would find enough volumes of copper, but unfortunately, we could not continue operations in next seasons. And there is sense to verify several parts of the area. Thank you very much for your attention, and I am prepared to respond to your questions. Thank you, Yuri, distinguished colleagues. So I propose that we close the session. Thank you very much, and hope to see you at our next sessions. Thank you.